Since the physical memory is much smaller than the addressable virtual memory, allocated pages don't always have to be present in physical memory in DRAM. Instead, the backing physical page frame can be repeatedly saved and restored to and from some secondary storage, like disk, for instance. This process is referred to as paging or demand paging. And traditionally, with demand paging, pages are moved between main memory and a storage device such as disk, where a swap partition resides. In addition to disk, the swap partition can be on another type of storage medium, like a flash device, or it could even sit in the memory of another node. Let's see how paging works. When a page is not present in memory, it has its present bit in the page table entry that's set to 0. When there is a reference to that page, then the memory management unit will raise an exception, and that will cause a trap into the operating system kernel. On an access, the memory management unit will raise an exception. It's called a page fault, and this will be pushed into the operating system, so it will trap into the operating system kernel. At that point, the OS kernel can determine that this exception is a page fault. It can determine that it had previously swapped out this memory page onto disk. It can establish what is the correct disk access that needs to be performed, and it will issue an I/O operation to retrieve this page. Once the page is brought into memory, the OS will determine a free frame where this page can be placed, and it can use the page frame number for that page to appropriately update the page table entry that corresponds to the virtual address of that page. At that point, control is pushed back into the process that caused this reference, and the program counter will be restarted with the same instruction so that this reference will now be made again. Except at this point, the page table will find a valid entry with a reference to this particular physical location. Note that the original physical address of this page will very likely be different from its physical address that was established after this demand paging process was over. If for whatever reason we require a page to be constantly present in memory, or if we require it to maintain the same physical address during its lifetime, then we will have to pin the page, and at that point we basically disable the swapping. This is, for instance, useful when the CPU is interacting with devices that support direct memory access support, or DMA.